Hello, in today's video we're going to be covering part 2 of section 5.2, using our radicals and simplifying radical expressions. So use the properties of radicals to simplify each expression. Properties of radicals here, what I can do is rewrite them as exponents. So 12 to the first power with an index of 3 means I divide by 3. And 18 to the first power with that index of 3 means I have 1/3 in my exponent as well. So like we have talked about previously, I can pull that exponent out and multiply my bases together. So what I really have is an index of 3, 12 times 18 underneath. So all of this in the middle we really don't need to do. As long as we have the same index, we can multiply what's underneath. Now from here I'm going to simplify. So I'm not going to multiply together yet. Let me figure out what groups of 3 I have before and see if I can pull anything out. So all together my 12 is 4 times 3 and my 18 is 6 times 3. 4 is 2 times 2. 6 is 2 times 3. So I'm looking for a group of 3 identical factors. So I see a group of 3 2's, which means that a 2 gets to come out of my radical. Cross these out. And out of those remaining factors, I also see a group of 3 3's. So a 3 gets to come out of the radical as well. And nothing is left inside. I grouped up all of my factors. So this simplifies down to just the number 6. B is going to be very similar, except since we have the matching index on our radical, I can combine these into a single fraction underneath the radical, and that allows me to now reduce the 80 with the 5. 80 divided by 5 is going to be 16, so I have the 4th root of 16. I'm looking for 4 numbers that multiply to give me 16, and that is the number 2, with nothing left, so this simplifies down to just the number 2. All right, pause the video and try these 4 on your own. Number 5, we should simplify to the 4th root of 81, which is just the number 3. Number 6 should be the 3rd root of 125, which is just the number 5. 104, I'll factor into 2 and 52, 2 and 26, and then 2 and 13. So I can take out a 2, and I'm left with a 13 underneath that cubed root. The 5th root of 3 over 4, there's really not much I can do here, but what we are going to be talking about in future lessons is how to get rid of your radical in the denominator. So really this is the 5th root of 3 over the 5th root of 4. So what I can do here is get the radical out of the denominator. That's what we call rationalizing. I'm going to multiply by the 5th root because that way I can multiply what's underneath. I have a 4, but I need 4 more of them in order to get my group of 5. And I have to do that on top and bottom. So on the bottom, 4 times 4 to the 4th gives me 4 to the 5th power. And that allows me to reduce my radical down to just 4. And on the top, I can multiply the radicands, the 3 and the 4 to the 4th, all underneath the same radical. And I'm going to go ahead and leave it like that for the time being. This is something that we're going to focus on more in future lessons, but I do want you to be exposed to it. Simplifying each expression here, as long as we have matching radicals, we can just add them. So I have 1 of my radicals and 7 more of those same radicals. So altogether, I've got 8 of those 4th roots of 10. And I can't simplify it any further because I'm not going to be able to find any groups of 4 in my 10. Same thing here. This is really a radical. These 8 to the 1/5 match. I have 2 of them, and then I have 10 more of them. So altogether I've got 12 of those 8 to the 1/5. And we can leave it just like that. C, the way it's written, I can't do anything, but maybe I can simplify. 2 times 27, 9 times 3, 3 times 3. I'm looking for groups of 3, and sure enough, there's a group of 3. So that gets to come out of the radical, but my 2 has to stay underneath, which actually works out nicely because now I have matching radicals. I have 3 of them, and I'm taking away 1 of them, leaving me with 2 of those cubed roots of 2. All right, take a moment, pause the video, and try these next few on your own. All right, check your answers and we'll move on. Got a few more to practice, so again, take a moment, pause the video, try these few on your own. I've got matching radicals, 8 and 5 more, which leaves me with 13 times the 4th root of 2. Matching radicals, I've got 7, and I'm taking away 17 of them, which leaves me with negative 10 times the 5th root of 13. Here I have matching radicals in disguise. I have 4 of them and 7 more, leaving me with 11 times the 9th root, the 4th root of 9. If I can simplify, hopefully I'll get a matching radical. I do see a pair of 3s, but the 2's left inside. I can't forget about the 4 that was also there. So 12 square root of 2 minus that 15 square root of 2. I have matching radicals. 12 minus 15 is negative 3 square root of 2. Same thing here. Let me simplify, see if I can get a matching radical. 9 times 7 is going to give me 63. My 9 breaks down, and then there's a pair of 3's. So I can take the 3 out, but the 7 has to stay underneath. And I can't forget about the 12 that was already there. And then I have 8 rad 7 in front. So 8 rad 7 plus 36 rad 7. Since I have matching radicals, I can add 8 and 36 to get 44 square root of 7. Lastly, I simplify my 4th root. 405 is 81 times 5. 81 is 9 times 9. 9 is 3 and 3, 3 and 3. There's a group of 4, which I need because my index is 4, but the 5 has to stay underneath my 4th root. And I have matching radicals, so I have 5 of those 4th root of 5. That brings us to the end of our part 2 of 5.2. Thanks so much for watching, guys. Have a great rest of your day.